Welcome dear students. In this video, I am going to explain simple applications of refraction of light. In our daily life, we come across many phenomena which are caused by the refraction of light. For example, twinkling of stars. Next example we will see. The sun is seen a few minutes before it rises above the horizon in the morning, while in the evening few minutes longer after it sets. This is also happens due to refraction or atmospheric refraction of light. Next example, if we will say, a print appears to be raised when a glass slab or a thick glass, transparent glass, is placed over it. The printed things will be seen a little bit up, raised. More examples if I will talk. A person's leg, if he is standing in a water or a tank, then we will find his legs appears to be short. More examples we will see. The portion of a rod or a pencil immersed in water appears to be bent. It will not look straight. It will seems to be bent. Next application if we will talk. The bottom of a water tank appears to be raised, or if a coin is placed at the bottom of the tank filled with water, we will find that the coins seems to be raised or up. So why it happens, how it happens? The reason is that it happens due to refraction of light. So let us see about real and apparent depth. So what is real and apparent depth? For that we will see, let we having a tank. Let the tank is there and it is filled with water. Suppose it is filled with water till this level. Water is filled. So, if we will keep a coin, let a coin is placed at this point. Suppose at point O, a coin, an object is kept. If we see, it will not look at this much depth. So this depth is known as real depth. So it is called the real depth. Real depth. But what happens? How we see this? For that, to see an object, the rays from this object starts traveling. So one ray is traveling in this way. As it reaches till this point, this is water, this side air. So ray is traveling from water to air, means denser medium to rarer medium. So it will deviate from its original path. For that we have to draw a normal at this point. So at the point of refraction, that means from where the refraction takes place, we will draw a normal. Let this point is name it as C. So what happens, as the ray is traveling from denser to rarer, so it will bend away from the normal. So ray will travel in this way. It will travel through this way. As we see from this side, so the coin will not look at this point. We can observe the coin at another point. Where will be that point? To find that, we will draw a normal from this point. Let it be like that. and let us increase this ray in the backward direction. At this point, we will see the image of that object O at point I, and this depth, suppose this point be A. So AI, that means this much depth, is known as the apparent depth. So it is known as the apparent depth, and this IO is known as the normal shift. So what is the relation between real depth, apparent depth, and the refractive index of the medium, that means water? For that we will see, as this is the incident ray, so this angle is angle of incidence I, and this angle is angle of refraction R. As we know, this green line and this black one is parallel, so and this OC is a transverse, so this angle will also become I, alternative angle, and as this is R, so this angle will also become R, corresponding angle. Now if we will see, according to Snell's law, if we will see, we can write mu AW, refractive index, relative refractive index of air, second medium, with respect to first medium, is equals to, or we can write like that, AW is equals to sin I by sin R. Write it as equation number 1. Now let us see, in right triangle OCA, sin I is equals to, sin I perpendicular by hypotenuse, so we can write it as AC by OC, and in triangle, right triangle AIC, sin R is equals to, again perpendicular by hypotenuse, so we can write it as perpendicular, that is AC, and hypotenuse, that is we can write it as IC. Now if we will substitute this value sin I and sin R in equation 1, so we can write from 1, substituting these values, we will get mu AW is equals to sin I, we can write, that is AC by OC, into sin R we can write, as it is the denominator, so we will write it as reciprocal, is IC by AC. This will cancel, and we can write mu AW is equals to IC by OC. Now as we can see, in this real practice, if you will say, then C and A will be very close to each other, so we can write as A and point C lies very close, then what we can write, at the place of C we can put A, so we can write it as mu AW is equals to, we can write it as IA by OA. So what we are getting in this, from here we can write, as we also know that mu AW is equals to 1 by mu WA. From the principle of reversibility we know this, so at the place of this we can substitute this value, so we can write as 1 by mu WA, relative refractive index of the water, is equals to IA by, we can write it as IA by OA, or mu WA is equals to OA by IA. That means we can say mu WA is equals to, I said AO or OA is real depth, So it is real depth by IA, that is apparent depth. So it is the apparent depth. So this is the one relation between real depth and apparent depth. So what is this? It depends upon the refractive index. If we will say one more thing we can find, that is the normal shift. So normal shift if we will find, then what we can write for that normal shift, that is, I am just doing it again for normal shift. So you have seen this using the Snell's law. Sin I and sin R we are finding from the triangles and substituting, we are getting this value. Now if we will find the normal shift, so how we can find that normal shift? That means in figure if you will see, then we can write it as IO shift, that is IO is equals to, we can write total, that means AO minus AI. If we will take shift, we can denote it by X. So X is equals to, if we will take AO common, then we will get 1 minus AI by AO, or as we can see, X is equals to AO is real depth, so we can write it as real depth into 1 minus, as we have seen in this IA, or we can see from here OA by IA, but this is the opposite reciprocal given, so we can write it as 1 by mu WA, refractive index of water. So this is the shift or normal shift. We can use this formula for solving the numericals. This normal shift depends on three factors. The first one is the refractive index of the medium. That means the refractive index of this medium, water. Higher the refractive index, more will be the normal shift. Second, the thickness of the medium. More will be the thickness, or higher will be the thickness, more will be the normal shift. And third one is the wavelength or the color of the light. For higher wavelength, if wavelength will be higher, as we know, then refractive index will be less and normal shift will be also less. So this is all about applications of refraction of light. In the next video, I will explain about critical angle and total internal reflection. Thank you students. Thank you for watching.